Chapter 20, Iron, Porphyrins, and Hemoglobin. Iron is essential for our cell function. You remember its binding of oxygen in the hemoglobin. We have about 4 grams of iron throughout the body. The majority of it is in the hemoglobin, but we do want to know that free iron is toxic. The next slide will describe this process for iron metabolism. It is ingested in the food source mostly through iron 3+ stage, and it has to be converted to ferrous 2+ and bound to a protein in order to be absorbed in the intestine. So within the intestine, the iron is oxidized and bound to the protein, becoming ferritin. Ferritin then is taken for storage within cells or over here to the liver and spleen. Or within the bloodstream, it is bound to a protein, apotransferrin, forming transferrin for circulation. So we have the 2 major forms, the storage of ferritin and the transport of transferrin. This basically goes through what we just discussed in the previous picture. Our body makes transferrin in relationship to the amount of iron it needs. So if our iron stores are low, then transferrin levels will increase. Ferritin is the storage component, and partially deproteinized ferritin is our hemosiderin that you saw in some of the different conditions where the iron is deposited throughout areas of the body. For our testing methodology, we need serum or heparin plasma. The other anticoagulants do interfere. We are going to actually measure the amount of iron 3+ that is bound to this transferrin. Most of the steps in methods consist of a colorimetric method where we release this 3+ iron from the transferrin and reduce it to the 2+ for binding to a color chromogen to make a color complex. And this reaction demonstrates that, and it shows that the color is directly proportional to the iron concentration, as we learned with Beer's law. Normally, about 1/3 of transferrin sites are bound by this iron 3+. We are concerned with the sites that are not bound, and that would be our unsaturated iron binding capacity. So that's how much more iron can this protein molecule hold. And therefore, the iron measurement and the unbound would give us our total iron binding capacity. When we're going to measure the total iron binding capacity, we supersaturate the specimen with extra iron 3+, and whatever is left of the known amount that we added is removed with a precipitating agent, and that is what we're going to measure in the supernatant, this excess iron that we added to our sample. This reaction is demonstrating this process. Therefore, the color intensity is indirectly proportional to the unsaturated binding sites. We've flooded the transferrin molecule to bind all those sites, and then we measure the surplus in our solution. So we measure the total iron, and then we measure the total iron binding capacity. We can calculate the unbound percent then. And a lot of physicians are interested in percent saturation. Percent iron saturation is the same thing as transferrin saturation. We will see increased serum ferritin levels with infections or inflammatory processes, specifically arthritis and renal diseases or liver injury. One that you did study in hematology is hemochromatosis. We have surplus iron in the ferrous state. It is toxic. It's deposited in various places of the body. We do measure this with an immunochemical test, ferritin testing. Here's a great table listing several disorders and diseases with the iron metabolism. It will list your serum iron value, increased or decreased, your total iron binding capacity, increased, decreased, possibly normal, and the percent saturation. And we also measure serum ferritin. So obviously with iron deficiency anemia, you're going to have low levels of iron. So your percent saturation is low along with your stores of ferritin. Our total iron binding capacity is elevated because we have lots of surplus available. Whereas in some of your anemias, you're seeing an increase in your iron and increase or no change in your ferritin. This chart is a good learning tool to help you remember. Basically, if you look at this, we've got our serum iron and ferritin, our iron saturation, and our total iron binding. We do also sometimes measure transferrin. Iron deficiency, we're low in iron and stores and percent saturation. So we have a lot of availability here. Where it's just about everybody else, we have surplus iron and ferritin and not much available binding sites. Iron deficiency, repeating what we just said off this other chart, it is an anemia. You have decreased serum iron, increased binding capacity and transferrin with a decreased ferritin and percent saturation. Some other lab testing that we do are free erythrocyte protoporphyrin, which is FEP. And sometimes we do some special staining on our bone marrow aspirates looking for hemosiderin. An iron overload could possibly be hemosiderosis, hemochromatosis, or sideroblastic anemia. Where we have surplus iron, transferrin could be normal. So we have decreased binding capacity. The saturation is elevated along with the ferritin in the stores.